Hello guys, so let us go and use compound angles to solve these given expressions. So let us start with the first one. Here they say evaluate cos 110 degrees, cos 20 degrees plus sine 110 degrees, sine 20 degrees. So by using our compound angle formula, we have to see, okay, in which form is the given expression, which compound angle formula does it relate to? So let us look at the pattern. Yeah, it's cos, cos, sine, sine with a positive. So let us see where, in which of these formulas is it, are we getting cos, cos, sine, sine, and a positive in the middle? It's this one, right? Cos, cos, sine, sine, and a plus in the middle. Obviously, this angle A and B represents 110, 20 degree. Okay, it's A and B, 110, 20 degree. A and B, 110, 20 degree. Okay, we can see it's AB, AB, 110, 20, 110, 20. They are repeating in both situations. So we're going to use this form over here. Cos, what is our A? It's 110 degrees. Minus, what is our B? It's 20 degrees. And so it's going to be cos 90 degree. Aha. 90 degrees is a special angle. And so what is cos 90 degree? It is 0 if we know our special angles. So always with the reason why we're using compound angles, we kind of want to simplify so that we can get a special angle either as a singular, or if these were special angles already, if all four of these angles from the start they were special angles, we wouldn't need to use compound angles because we know our special angles and how to convert them into fractions, right? So yeah, we can see that 110 and 20 degrees, they are not special angles. So let's use a compound formula angle to see if we're going to get to a singular special angle, and we did. By subtracting 110 and 20 degrees, 90 degrees is a special angle. We're able to evaluate that it's 0 because we know our special angles, right? That's the main point of compound formulas for most situations. Let's look at another next example. So yeah, we are given sine 13, cos 32, cos 13, sine 32 degrees. Let us look at the pattern. It's sine, cos, cos, sine, sine, cos, cos, sine, and a positive at the middle. Where is sine, cos, cos, sine? Sine, cos, cos, sine. It's also here sine, cos, cos, sine, but we're working with a addition, not a subtraction. So it's not this one, but it's this one because there's an addition. So we're going to use this form over here. Sine, what is our angle A? A. It's 13 degrees. Our angle B is 32 degrees. When you add them, you get 45 degrees. Aha, special angle. And so what is sine 45? We know it to be square root 2 over 2. Great. On this example, so there are two ways in which you can tackle this one, right? You can indeed use compound angles, or you can use reduction. How are we going to use reduction? Let us look at our cos diagram. We know that, yeah, it's 180 degree minus particular angle, 180 plus, yeah, it's 360 minus 360 plus. This 300 is closer to 360, right? Then it is closer to 180, so we can use either of these forms, this one or this one. But we can see we can use this one. We can just say sine 360 degrees minus 60 degrees, because 360 minus 60, oh, let me write that again. 360 minus 60 degrees. It's 300, right? So we can use this form over here. We did use that form. It's in the cos quadrant, so it receives negative. You keep the ratio. You keep this angle, remove the 360 minus. And so 60 degrees, it's a special angle. So negative square root 3 over 2. Great, that's one way of using it. The other way, if for some reason the question wants you to use compound angles, it's like, okay, I mean, this is pretty much the simplest way to break down this 300 degrees into two angles by saying 360 degrees minus 60 degrees, right? So okay, yeah, let's use compound angles. Let's see which form does the sine 360 minus 60 degree relate to here. So it's sine angle minus angle. Where is sine angle minus angle here? Oh, it's here. Sine angle minus angle. So we're going to use this form. So sine angle, what is the A here? A. So our A is 360. Sine 360 degrees cos another angle which is 60 degrees minus cos our A, we already established it's 360 degrees. You see now the angles are changing with each trig ratio. Sine 60 degrees, right? It's a negative, remember. Then it's not a positive, don't confuse it there. And then is 60 is a special angle, right? Is 360 a special angle? It is. So I know that I said these are special angles. They are. But it's not only these angles, it's also their relatable angles. So for instance, in this case, let us draw the sine graph. Sine, we know that here it's 0 degrees, here it's 180 degrees, here it's 360 degrees. So here 360 degrees is where the graph is 0, but also 0 degrees. So this 0 is somehow related to 360 degrees because they are both at 0. It's also related to 180 degrees. So it would also be related to 180 degrees. So 0, 180 degrees, and 360 degrees, they are also special angles. These two, they are also special angles because they are related to 0 degrees. So whatever other angles these other special angles are related to, they are also special angles related to each of these degrees, right? That is very important to notice. So 0, 30, 45, 60, 90 degrees are not the only special angles, but also the angles related to them. So we know that we just established that sine 360 degrees is the same as sine 0 degrees. You can write it or you can just get straight to the answer, but let me just write it. 360 degrees related to 0 sine 60 degrees. And so what is sine 0? It's 0, right? 0, what is cos 60? It's 1 over 2 minus cos 0, it's going to be 1. Sine 60 is going to be square root 3 over 2, right? And when you simplify it, it's going to be negative square root 3 over 2. So you see we got the same answer as when we did that reduction formula where we established, okay, it's minus negative sine 60 degrees, negative, my goodness, square root 3 over 2. So they are the same, different methods. You want to go with the method that is going to be asked, or if they're just going to give it to you like this and say evaluate, you can use either and or. Right, you just want to be strategic with when you want to use compound angles and when you want to use reduction.